A civilization that's level 1 on this Kardashev scale has the power to harness the energy of its home planet. On our home planet, there's the energy of volcanoes, of tornadoes, of hurricanes, and of earthquakes. This is Earth exhibiting a display of energy that typically we run from or die from. If we could control all of that, that would be an extraordinary state of our civilization. Tapping a volcano of its energy so that you now can use that energy to run the city that the exploding volcano would have otherwise leveled. Civilization type 2 on a Kardashev scale is, well, what else is generating energy out there? Well, our host star, the sun. So imagine we had total control over the sun's energy. Right now, we just set up a few solar panels here and there, and it's, whatever energy happens to get there on a clear day and not at night, that we're tapping some of the energy of the sun. But the sun is emitting energy in every single direction in space. So imagine you could harness all of that energy. That's vastly more energy than is contained in the Earth. That would be a civilization of extraordinary power. Would they have warp drives, wormholes? Who knows? They'd be traveling across the galaxy, between galaxies, because the energy is so plentiful and they have access to it and especially can control it. It's a big factor when you have access to awesome supplies of energy. Civilization type 3 on the Kardashev scale would be you can control all the energy of all the stars in your galaxy. So our galaxy, the Milky Way, has several 100 billion stars. So if you found some way to harness all of that, oh my gosh, this is, who can imagine what that is? Can you create universes? Who knows? I don't know. I can't think that far ahead. What I do know is that it would be awesomely dangerous, as any new access to energy has always become when in the hands of bad actors on the geopolitical stage. For a sample of millions of stars, they found 7 candidates that might be one of these type 2 civilizations. Or it could be some gas cloud that was warmed up and is radiating infrared. So, of course, the press loves aliens. If your first guess is, there's an alien civilization that's making this infrared, the press will talk about the work. If it's, well, it could be gas clouds that have been warmed with dust in them that have been warmed by this energy that's been radiated, and it's masquerading as what could be a type 2 civilization. You can't rule that out either. As a scientist, just because you don't fully understand what you observed, it doesn't mean aliens did it. That shouldn't be anyone's first guess. The universe brims with mysteries and physical phenomenon we're still discovering. A few years ago, Freeman Dyson, a brilliant physicist, he came up with the idea of an entire sphere. So a Kardashian civilization type 2, they just simply have control over all of the energy of their host star. One way to do that is to build a sphere around it that completely encloses that star. So no energy escapes your detectors, your panels. It just needs to have the power to tap that energy for whenever it needed it, for whatever purpose. And you can imagine sort of strips of panels. It wouldn't have to be the entire, let some energy get out. If you needed it, maybe those panels can close up and open again, like those stadiums that open and close in the rain or in the hot sun. And there's no telling what inventions, what discoveries, what new understandings of the universe would unfold in those civilizations versus ours, a type 0 civilization. If there was a type 2 civilization, could you detect it? What would it look like? Well, a couple of things. If you're looking at invisible light, the kind of light that the sun primarily gives off, they would be blocking that light to absorb that energy for their needs. So you would see an ordinary star just begin to disappear as they built structures around it to absorb that energy. There's an interesting fact here. Well, there's no such thing as a free lunch in the universe. You can't just take the sun's energy and then have the energy disappear. It manifests in other ways. It manifests as heat. If there's a civilization that managed to completely enclose its host star, it would get rid of all the visible light because that's high quality energy that it's using. It takes that light through the solar panels. The star would slowly disappear from a, quote, a regular looking star and would ultimately appear as a red glow in your infrared telescopes.
I'm thinking if we were being visited, somebody would have some good footage. If we were being visited, I'm thinking maybe Google satellite images would catch spaceships that are not airplanes moving on our surface. If we were being visited, I'm thinking we'd have something better than fuzzy monochromatic video, objects that apparently reveal themselves only to Navy pilots. To me, is insufficient evidence to excite my interest, my research interest in devoting time to finding it out. But it definitely has excited other people. I have not stopped them. I am not saying defund the military program on UAPs.
But when you go into space, the country borders go away, except for two places. There are two places. You can still see two borders from space. One of them in the daytime, you can see the border of Israel with surrounding deserts, because Israel irrigates, and so it's green, and the surrounding areas are brown. You can see that from space. Another border, which you can see from space at night, is, of course, North and South Korea, right there.
Yeah, that's crazy.
And that's punched up. I mean, if you're in the dead of night, you don't know the difference between the ocean and the land as your sight line crosses North and South Korea. And so if you look at the GDP per capita differences between Israel and surrounding nations and South Korea and North Korea, it's factors of 8, 9, 10, 12. So space can reveal economic inequities in at least those two places, which is itself kind of a stunning fact.
In Columbus's voyage, they went on some stretch of time and they didn't have food, and they had Indians from that they'd brought on board, as well as some of their own crew, and people were dying. And so at sea, what do you do with a dead body? You throw it overboard, of course. Okay, so a person who's keeping notes said all the Indians they threw overboard floated face down, and all the Christians. I guess that could happen statistically, perhaps. I don't know. Yeah. But now we have his handwritten notes, eyewitness testimony of something that is completely fulfilling his own worldview's expectations of how things should be. I was in Alaska, and there was a deer and a grizzly bear. Must have been 300 yards away. Way down in the valley. And the deer noticed it, and it was eating, but it was eating very cautiously, always looking to the bear. And I'm saying, if it could notice a bear 300 yards and be cautious of it, why can't it know a Ford 250 barreling down a road?
Because it's not natural.
Well, figure it out. I mean, it's a mammal. It's got a brain.
That takes forever.
Let me get angry with the deer for a second. And how come we haven't killed all the stupid deer by now? So the ones that are left are the ones that recognize that cars killed them. Everyone that doesn't, they die. And the ones that have a little bit of genetic variation that figures it out, they'll survive. Old enough to remember the 1950s and 60s, people were imagining the future, the home of the future. Well, technology was automating things. So everything was a button. So the home of the future was just a button. And then people imagined that the future evolution of humans, we'd grow a big index finger because you had to be pushing buttons all the time.
Right.
And now, no, we don't have buttons all over the house. Let's go right up to 1968, 2001, A Space Odyssey. This is imagining a world in 2001. Oh, computers will be really big then. So we imagined a world with transportation, motion, and actions that all require energy to enable. And those worlds came out of the heads of people who extrapolated forward, and they did not understand that the real action was in information. Information is what became cheap, not energy. And when information becomes cheap, I have the world at my fingertips.
Here's an interesting fact. I lost sleep for a week over this. Ready? The common ancestor between humans and mushrooms split later than its common ancestor split with green plants. What that means is we and mushrooms are more alike than either we or mushrooms are to green plants.
Well, mushrooms breathe oxygen.
All I'm saying is you grill a portobello mushroom? What's the first word people use to describe it?
The test for whether you really left your body or whether you were hallucinating it is get some writing that faces the ceiling up above your body, okay? And they've done this experiment. And if you're floating above your body, above that piece of paper, when you come back to life, you should be able to say what's written on that piece of paper. And that is yet to happen.
If you get above it.
Yeah, if you get above it, correct. That is yet to happen. That'd be really good.
Where would that piece of paper be suspended?
Yeah, no, you have to put it up on a shelf or something. Yeah, you'd be able to put it in a way that it would be clearly...
But then the person would have to die knowing that piece of paper was there and then be brought back?
Possibly. I mean,
So you'd have to tell them, hey, I know you're going to die.
you're going to die.
We're gonna
If you come back,
Yeah.
I have a piece of paper up here.
That
Go
seems
read
like
from it.
a pretty ridiculous experiment to try to
if
achieve.
you care, wait, pause. We used horses for thousands of years. Now you go from 1910 to 1930. 1930, you can't give away a horse. Not in urban areas, no.
Isn't that crazy?
Within 20 years, we went from horses and an entire industry that supported the horses. The buggy whips, the carriages, the stables, the
Blacksmiths.
food, the blacksmiths. An entire industry vanishes within 2 decades, basically within 2 decades. And you're going to tell me when are automatic cars come? We already have them, and when it's ready to go down, it's going down. My kids are 20 and 24. They don't want to know how to drive. They can't wait until the self-driving cars. They want nothing to do with it. And by the way, you might say, but how about people who love to drive? Then we build tracks for you.
Oh, God.
No. There are people today who like riding horses. They don't do it in the street. You go to the stables. I make a prediction by the year 250. I have a bunch of predictions here.
Okay.
Neuroscience and our understanding of the human mind will become so advanced that mental illness will be cured, leaving psychologists and psychiatrists without jobs. In a shift that echoes the rapid conversion from horses to automobiles in the early 20th century, self-driving electric vehicles will fully replace all cars and trucks on the road. If you want to be nostalgic with your fancy combustion engine sports car, you can drive on specially designed tracks, akin to horse riding stables of today. The human space program will fully transition to a space industry supported not by tax dollars, but by tourism and anything else people dream of doing in space. We develop a perfect antiviral serum and cure cancer. Medicines will tailor to your own DNA, leaving no adverse side effects. We will resist the urge to merge the circuitry of computers with the circuitry of our brains. Surely in your life, you have taken an average of numbers before. The first time anyone ever did that, to realize that maybe there's some interesting result here, was after the invention of algebra, trigonometry, geometry, and calculus.
Really?
Statistics is just something that the human brain, it's just not natural. It is completely foreign to us. We don't know how to interpret simple random events because we want to give meaning to them. You know the thing where you're in some other country, in some other city, and you meet someone like a childhood friend.
Yeah.
And you say, small world.
Yeah.
That's your first thought, right? Small world. Okay, here's how to cure that. Okay, next time you're in a foreign city, go up to every single person you walk by. If they say, no, I don't know you, then say, big world. You'll do that millions of times. And the proper statistics will then get recorded. So no, it's not a small world, it's a fucking big world. If you're in 0G, a fire basically puts itself out. So think about when you burn a candle on Earth, so you light the wick. Does people have candles anymore? They forgot what a candle is. You light it with a match that you used to get from smoking lounges at bars. All right, so you light the candle and it stays lit. The fuel is the wax. The oxygen continually comes in because it heats the air around it and the air rises. Hot air rises and fresh air comes in from below and has fresh oxygen. So the candle will stay lit until it burns all the way down. In space, if you light a candle, you can light the candle. It'll heat the air, but the air will not know where to go because it's not lighter than everything because it's in 0G. It'll stay clustered around the candle. The candle will use up all the oxygen in that bubble and then it'll put itself out. I get blamed for killing Pluto, but I was an accessory for sure, but I definitely didn't kill Pluto. That dude killed Pluto. All right, he found another object that was basically the size of Pluto out there. So either you make that a planet or you demote Pluto.
And how much smaller is Pluto than, let's say, our moon?
Oh, so don't get me started. Our moon has 5 times the mass of Pluto.
Wow.
So the Pluto was lame from the beginning. All right, we thought it was big. We wanted it to be big. We made it one of us, one of the 9, and its size didn't settle out until the late 1970s, where we had better and better, more accurate ways to measure its size, and that's when we learned it's small even compared to our own. But granted, we have a big moon, but if you're not going to think our moon is a planet, you're certainly not going to think that Pluto is a planet.
Just a couple decades ago, we had speculation of other planets, but we really didn't have any tangible proof.
Ask who here is born since 1995. Okay, and your audience leans young, so there'll be some fraction of the audience that'll raise their hand. And so what I do is I knight them as Generation Exoplanet. because 1995 was the first year that a planet outside of our own solar system was discovered. So they have been alive only during a time where we've known of other star systems.
That's so crazy.
Generation exoplanet. That's what I want to start that movement. This is the advance of tech. That's not just science advance. That's engineering and technology and telescope quality and imaging quality. And there's a lot that goes on to the advance of science. It's not just how clever you are in an Einsteinian way. It's, do you know good engineers to build a device to make the measurement? In the movie Monsters, Inc., those doors were four-dimensional portals. They take the doors home.
Yes.
They open the door, and they're in the closet of the kid that they're going to terrorize.
Yes.
That is what access to the fourth dimension looks like. So desk is 2 dimensions. It's got length and width. And I can start putting papers on this desk. If I'm an ant living in this surface of the desk, I say, no more room. But wait a minute, we are 3-dimensional people. And I can put an organizer and stack things vertically. So I can take a sheet of paper, and now I can put it higher up than the surface of the desk. The ant will say, where did it go? Oh my gosh, you would have made that paper disappear into a 3rd dimension. So now let's up this example by a dimension. You're storing boxes in a room. No, you didn't. Let's open this 4-dimensional door. You open it, put the boxes through the door, close the door, box is gone. That is a portal to a 4th dimension that can hold vastly more content than what you're stuck storing in the 3-dimensional space of your room. I'm not judging the biophysiology of these creatures, but they got the physics of 4-dimensional portals completely accurate. Death in space is nowhere near as spectacular as movies would have you think.
Yeah, they make it seem like if you take that helmet off, you just immediately freeze up.
Yeah, no. I mean, you can go into what happens is there's nothing making you cold other than you radiating heat from your skin.
Oh.
So you only get as cold as quickly as you can radiate away heat. That's all.
So it would take quite a while.
Oh, yeah.
You just have no air, so you'd suffocate quicker.
Yeah, you'd suffocate. Oh, yeah, you'd suffocate long before you saw anything like that happen. So just think about it. There's nothing touching you that's making you cold. It has to wait for you to radiate away. That's what's happening. Okay? And so you'll feel very cold very quickly, but you're not going to die from that fast, which will try to come, because in the vacuum of space, you don't have the air pressure tamping down the dissolved gases. So you take away the air pressure, then the dissolved gases will begin to bubble out of your blood. The rotation rate of the space station, I calculated that. What G-force would you have on the outer perimeter of the space station in 2001? And I did the math, and I forgot the exact number, something like between 2 and 3 Gs.
Oh.
And I said, why would you do that? That's stupid. You wouldn't do that. And I realized if they rotated it at the rate that would give you 1 G, it would be way too slow to make an interesting scene. So I gave it to him. I said, I'll give you 3 Gs. Because the Strauss waltz, as the thing turns, and the space shuttle that's approaching it matches its rotation rate with the opening in the center of the space station. This whole ballet, this entire ballet...
Wow, that's cool looking.
...happens at a stately but real pace, okay? But that pace gives him a 3 Gs of gravity. Mark Twainian license, where he says, first get your facts straight, then distort them at your leisure. That is what I'm holding artists to. Do you know the size of your own hat?
I have a pea head.
Hat size has mathematical significance.
Please tell me it's not in relation to...
You take a tape measure and measure the circumference of your head.
Okay.
Write down that number. Divide it by pi. That's your hat size.
Oh.
Yeah. If the circumference of your head is 6.5 inches, you're some other species. You're a rhesus monkey. I don't know. So I was in a hat shop because I always wanted to own a top hat that you can pop into.
Oh, yeah.
I always wanted to one. And they make hats. So they measured my fat head and they wrote it down and said, you need a size 8 or something. So I said, fine. Do you know where you get this number? He said he didn't know. And I told him. He said, really? And so we did it. And so I'm glad that he was skeptical, so then you can do the experiment. We did it on his head and his assistant's head, and it all came out. It was all perfect. And so he wanted me to write it out. So I wrote it out, and I signed it, and it's on the wall of his hat shop.
Jupiter's 90% hydrogen. Can we tell it's a failed star? If it's
90% of the universe is hydrogen. About 8% are helium atoms. When you see that ratio in big gaseous things, they're mostly made of stuff the universe was born with. So... if stars are made of 90% gas, because there's more mass, there's more weight, there's more pressure. And when you have pressure in the core, the temperature rises. And as the temperature rises, there's a threshold where you start fusing nuclei in the presence of heat. Thermonuclear fusion.
That's where you get that word from. The sun is undergoing thermonuclear fusion in its core. The high pressures, high temperatures are squeezing together hydrogen atoms, and out the other side comes helium atoms. And the helium atom has less mass than the hydrogen atom. Where did the mass go? E equals mc squared. It became energy. And that energy is sustaining the star. Jupiter didn't have enough. You can have a political truth. That's something that becomes true because of how frequently it has been repeated. And that's the foundations of brainwashing and brainwashing and propaganda. You are superior to everyone else. You are German in the Third Reich, and you are superior. Okay, that becomes true to you. You hear Trump running against Hillary. Anytime he mentioned her name, what was the moniker?
Crooked.
Crooked Hillary.
Yeah.
After a while, he said, "Oh, Crooked must be your first name. She must be crooked. It's repeated enough." We're on the Serengeti, and you see something repeat. You're going to believe that that's true because it probably is true because it repeats. Something happens in nature that repeats. Politicians and others who want to influence you, advertisers as well, have hijacked this evolutionary urge deep within us. They can make you think anything is true, even if it's not, because your evolutionary urge to think something that repeats is true is tapped by that effort. If you're at a plane at 5,000 feet and the wings break off and it falls, okay? If you're on a religion where you are sure it's the one true religion, which of course is the thinking in practically every religion. Christians, the one true religion. The Muslims, the Jews, the Hindus, the atheists, the animists, they're all false gods, okay? Yeah. You're in the plane, and the plane is about to crash. So all the Christians pray for their own souls and for the souls of other Christians. The plane crashes, the Christians walk away, and everyone else is dead. Oh my gosh! That's some remarkable evidence that prayer works, that Christianity is the one true religion and the other ones are false. But when planes fall from 5,000 feet, everyone dies. There's plenty of ways I can think of having evidence that your God is the one true God and it does not exist. That's all I'm saying. And in a free country, no one is going to take that from you. Newton's laws, okay, have basically been replaced by Einstein's relativity, his special theory of relativity for motion and his general theory of relativity for gravity. That was Newton's contribution to us, motion and gravity. Newton's laws are no longer, they're not where they were previously used. They still work. We went to the moon with Apollo using Newton's laws. But there are places where Newton's laws fail because a broader spate of experimental evidence showed that at high speeds and high gravity, Newton's laws fail. You need another understanding, a deeper understanding. Then came Einstein. So I don't want to call them immutable.
Okay.
But Newton's laws are objectively true in all the realms in which they've been tested. If you're at a plane at 5,000 feet and the wings break off and it falls, okay? If you're on a religion where you are sure it's the one true religion, which of course is the thinking in practically every religion. Christians, the one true religion. The Muslims, the Jews, the Hindus, the atheists, the animists, they're all false gods, okay? Yeah. You're in the plane, and the plane is about to crash. So all the Christians pray for their own souls and for the souls of other Christians. The plane crashes, the Christians walk away, and everyone else is dead. Oh my gosh! That's some remarkable evidence that prayer works, that Christianity is the one true religion and the other ones are false. But when planes fall from 5,000 feet, everyone dies. There's plenty of ways I can think of having evidence that your God is the one true God and it does not exist. That's all I'm saying. And in a free country, no one is going to take that from you. I made a list of the most expensive things we've ever done as a species. We could agree with most of what appears on this list. There's the Great Wall of China, the Manhattan Project, the Apollo Project, the Columbus voyages, the pyramids. Then I asked, what was the motivation for them? And in my list of the most expensive things we've ever done, I came up with only 3 drivers. The number one driver of them all is war. That gets you the Great Wall of China. That gets you the Manhattan Project. In fact, that also gets you the Apollo Project. It's the I don't want to die driver. What's next? The prospect of gaining great economic wealth. And that is the praise of royalty or deity. This is the effort to appease an entity that is either perceived to be or is more, or literally is more powerful than you are. So that's how you get the pyramids. So I said to myself, if we are going to go to Mars and Mars is expensive, it's going to have to satisfy one of those 2 criteria. Otherwise, we're just never going to Mars. If you double NASA's budget and we go into space in a big way and it's writ large across the newspapers, we resurrect the innovation culture that prevailed 40 years ago. Nobody today is thinking about tomorrow. Nobody's thinking about a World's Fair. I don't remember the last time I saw an article dreaming about the city of tomorrow. They all ended. You know when they ended? After we stopped going to the moon. So I submit, a healthy NASA is a healthy America. And if NASA's healthy, then you don't need a program to convince people that science and engineering is good to do. Because they'll see it writ large on the paper. There'll be calls for engineers to help us go ice fishing on Europa, where there's an ocean of water that's been liquid for billions of years. We're going to dig through the soils of Mars and look for life. That'll get me the best biologists. Look at the NASA portfolio today. It's got biology, chemistry, physics, geology. A healthy NASA is a flywheel that society taps for innovation. Kennedy's speech, May 25th, 1961, 6 weeks after Yuri Gagarin had gone into orbit and come back safely. We didn't yet have a vehicle that wouldn't kill one of our astronauts going into orbit. John F. Kennedy stands up in his second State of the Union address of that year and utters these prophetic words: "We will put a man on the moon and return him safely to Earth." We collectively have cleansed our memory of that era and of that speech. And in the cleansing, we think of Kennedy as a visionary, as a charismatic leader who dreams of space like the rest of us. He talks about exploring space and the value of that to mankind. Go 2 paragraphs earlier in that same speech. What does he say there? If the events of recent weeks, he's indirectly referencing Yuri Gagarin. If the events of recent weeks are any indication of the impact of this adventure on the minds of men everywhere, then we must show the world the path of freedom over the path of tyranny. It was a battle cry against communism. That's the war drive. It's not just an expansion that'll continue forever. Right. It's an expansion that will accelerate.
Forever.
Because it is a property in the vacuum of space. That's what we call dark energy. You can do the math on this. If that acceleration goes unchecked, it'll start ripping apart things that would otherwise retain their integrity from their gravity. So first, they're galaxy clusters. Even in an expanding universe, they'll want to stay together. With the accelerating expansion, it'll start no matter pulling them away. Once it's destroyed the galaxy cluster, now it's going to start working on the galaxy, which are tightly bound systems of stars. As the universe continues to expand, the strength of that expansion will become greater than the binding gravity of the systems themselves. Ooh. So it'll start ripping apart galaxies. Then you don't have galaxy clusters, you don't have galaxies, now you just have stars and their planets. It'll start plucking the planets away from the stars. So it'll start becoming stronger than the electromagnetic forces that holds matter together. Damn. Imagine this is, we have a rubber band. Okay. You take one end and I'll take one end. All right. So you feel the force tugging on us, right? So this was originally the gravitational force that was holding galaxies together. Okay. But this dark energy broke that apart. Then there's the force of the intermolecular force. They broke that apart. Okay. But the universe is getting more and more stretched. Right. Okay. What we don't know is that, is there a limit to how much the physical universe can stretch in response to this dark energy? Okay. Because once you're down to a proton and it rips apart a proton, then you're left with quarks. But then what happens? Can you rip a quark apart? We don't know. We don't know. What? But then what could possibly happen is... Oh, no. No. Ouch! So we call this the Big Rip.
What would it be like to die by going into a black hole?
If you go feet first dive, so your feet approach the black hole faster than your head does. Okay. Because the gravity is stronger at your feet. Okay. And at first, you're stretching, and that kind of feels good. Right. Initially. Therapeutic stretch. Yeah. Until that difference in gravity becomes greater than the molecular forces that hold your flesh together. Ah. And at that point, you snap into 2 segments. Right. And then each of those 2 segments, eventually they snap into 2 segments. You go from 1 to 2 to 4 to 8 to 16, and you're the stream of particles descending down.
Now, is that, are you feeling pain or are you not?
The fabric of space and time funnels you. Yes. So that, in fact, you're occupying a narrower and narrower cone of space. Right. So you're getting extruded through the fabric of space-time, like toothpaste through a tube.
As an astrophysicist, you have said that you are frustrated by how the stars and the cosmos is portrayed on television. You think that people don't pay enough attention to accuracy.
It's bad. Like, in fact, forgive me, but your moon is just completely wrong. It's too large, it's the wrong phase, it's in the wrong part of the sky, and it's facing the wrong direction.
Where should the moon be?
You come on in the middle of the night, you can't have a crescent moon.
Because there aren't crescent moons?
Not in the middle of the night. No, they're gone. Crescent moons, unless you live in the Arctic. Yeah. They're gone. So that moon should be like turned this way. Right. It should be like a half moon or more. Right. And it should be further over New Jersey, and it should be smaller. particularly in the monotheistic traditions, that God is typically described as being all-knowing, all-powerful, and all-good. Yet I look back through history. I can choose many examples, but a famous example is the earthquake in Lisbon, Portugal. When was it? 1755, somewhere around there. 80,000 people died. By the way, that earthquake took place on All Saints' Day, in the morning. Most people were in church. Churches were the largest structures of the day. If you have an earthquake, what's the first building to collapse? It's the ones that are the largest, the most susceptible. So, people died in churches. Then there's a tsunami that basically wiped Lisbon off the map. Either God is not all good, if we define good as being in the interest of your health and longevity, that's a pretty simple definition of something that's good for you, or God is not all powerful. But it's not clear whether God could be both of those at the same time for that event.
When the sun is 99% covered by the moon, with just a thin little smidgen, the amount of light reaches Earth from that smidgen equals the light of 10,000 full moons. So the moon is only reflecting not much more than 10% of the sunlight that hits it. Right. The rest is getting absorbed. Photon is a packet of energy, and it doesn't make sense to think of it as having temperature. Then when you absorb it, it vibrates the molecules in that which absorbed it, and that is measured as temperature. When the energy you absorb increases the vibration rate of your molecules, you experience that as heat.
That's it.
What happens at the beginning of the universe when the entire universe was the size of an atom? Whose rules are in charge? You have a shotgun wedding.
There you go.
Between quantum physics and general relativity. And all of us are pretty sure that quantum physics wins. And in so doing, quantum physics, where it pops particles in and out of existence, it could pop universes in and out of existence. Whole universes, if the universe is the size of a particle. Let's go back in time when the whole universe was the size of a particle, and we are just one of them. Each one with a slightly different law of physics. There's no limit on how many of these universes there could be. Let's say there's infinite. If there's an infinite, that means there's every possible combination of all particles there ever were.
Right.
Including combinations of particles with you on another universe.
The light that goes into a black hole, how is that spaghettified?
So let's take a wavelength of light. Here's a wavelength of microwaves, a couple of centimeters across. As this falls into the black hole, if you're watching that fall into a black hole,
the wavelength stretches.
Yeah. We said red because we talked about visible light shifting to the red side of that spectrum.
Gotcha.
But I'm using microwaves, which is already redder than the red, but we kept the term. It's getting bigger. And it would then become sort of infinitely redshifted as it goes down to the bottom of the horizon. The photon of longer wavelength than the size of the black hole itself into the black hole. So there's a limit to how big is the wavelength it fits in.
People like Jeff Bezos and Elon Musk and others who've become obsessed with space, they're wasting their money too. We have so many problems on this planet.
The billionaires are opening a new tourism industry. I don't have a problem with that. This is what the dawn of aviation was. Only rich people and famous people flew in airplanes in the 1920s and 30s. Then it became a whole industry. Now millions of people fly every day. If you were around back then, are you saying, stop wasting your money on this stunt? This biplane thing, well, this is a stunt. So dare I say, though you are the host of this program, that I'm glad people with attitudes such as that do not win the day among those who are trying to advance what civilization can be.